You're looking at a live view of the Falcon Heavy on historic launch pad 39A at Kennedy Space Center, awaiting liftoff at 6:35 p.m. local time. Welcome to our live webcast of the Falcon Heavy arabsat 6A mission from SpaceX headquarters in Hawthorne, California. My name is Jesse Anderson, and I'm a manufacturing engineer here at SpaceX. I'm so excited to be here with you today, along with my co-hosts, bringing you coverage of the second launch of Falcon Heavy. It's the first Falcon Heavy launch carrying a payload for a customer, and tonight our customer is arabsat.
And I'm Alex Siegel. I'm a material planner here at SpaceX. We first flew our Falcon Heavy vehicle a little more than a year ago. It is the world's most powerful operational rocket by a factor of 2. With 28 engines, 3 boosters, 3 separation events, and 3 landing attempts, there's going to be a lot of activity happening all at once. The payload tonight is a geostationary communications satellite, which will provide state-of-the-art communication services to customers in the Middle East and Africa.
Tonight's launch window is about 2 hours long, and we're planning to launch at the top of that window. If we're unable to launch tonight, our backup window opens up on Saturday, April 13th. We're currently at T-minus 14 minutes and counting, and all systems are go in Cape Canaveral.
Today, Falcon Heavy will deliver the arabsat 6A payload to its intended orbit more than 20,000 miles above the Earth's equator. That's significantly higher than normal, which is why we're flying a Falcon Heavy. Now let's take a closer look at the rocket. Falcon Heavy is essentially 3 Falcon 9 rockets strapped together, which means it can carry much larger payloads not only to Earth orbit, but to the Moon and Mars as well. Like the Falcon 9, Falcon Heavy is a 2-stage launch vehicle. The big difference, of course, is that the Falcon Heavy first stage is comprised of 3 cores, and Falcon 9 only has 1. Each one of these cores has 9 Merlin 1D engines, making for a total of 27 engines overall, as you can see on your screen. Now, altogether, these engines produce over 5 million pounds of thrust, equal to 18 747s at takeoff. In fact, the engines produce so much power that we don't run them at full thrust all at once until after liftoff. For the mission today, each one of these 3 Falcon 9 boosters is brand new. It's also going to be the first time we are flying Falcon Heavy with our upgraded Block 5 cores, which feature more lift capacity, a beefed-up heat shield, and other changes to make the boosters more reliable and easier to reuse.
During ascent, Falcon Heavy will throttle its thrust up and down on both side boosters and the center core to balance aerodynamic and structural loads on the vehicle. About 70% of the way through the first stage burn, the 2 side boosters will separate and come back to Earth for a simultaneous landing at Cape Canaveral Air Force Station on Landing Zone 1 and Landing Zone 2. At this point, the mission will proceed just like a standard Falcon 9 flight. The center core will keep firing for another minute, then we'll perform a standard stage separation from the second stage. We will attempt to land the center core on our drone ship, Of Course I Still Love You, which is currently stationed about 535 nautical miles off the coast of Florida in the Atlantic Ocean. It's worth mentioning that for this mission, bringing back the center core is challenging. If we are able to land all 3 cores tonight, it will be particularly exciting. The second stage is exactly the same as any other Falcon 9 flight. Tonight, the second stage will be sending our payload to geosynchronous transfer orbit. The spacecraft will then maneuver into a geostationary orbit more than 20,000 miles above the Earth's equator. Now, to put that into perspective, that's equivalent to almost an entire trip around the world, traveling along the Earth's equator.
Speaking of the satellite, it is safely enclosed inside the 17-foot diameter payload fairing, which is the pointed cone on the very top of the rocket. This protects the payload from aerothermal loads, heating, and contamination during ascent. Now, once we reach the vacuum of space, we will jettison the fairing as the second stage continues on its journey to orbit. While Mr. Steven, our ship, will not be supporting today's mission, we do plan to recover the fairing pieces from the ocean using our recovery ships Go Searcher and Go Pursuit. And lastly, you'll notice the tall structure next to the rocket, which we call the fixed service structure. Its primary function is to provide passengers access to the Crew Dragon vehicle during crewed missions. But since we do not have any passengers aboard today's flight, the fixed service structure does not have a role to fill. Now let's check in on how the countdown is going.
Good Thursday afternoon. I'm John Innsbrucker, the Falcon Principal Integration Engineer at SpaceX. We are T-minus 10 minutes, 28 seconds from the launch of the Falcon Heavy. As I like to say in my updates, the SpaceX team is working no significant issues and is on time for launch. Now, Falcon Heavy rolled out to the pad with the payload early Wednesday morning and went vertical about 6 hours later. Now, after yesterday's scrub, the vehicle remained vertical on the pad. The pad deck was cleared at about T-minus 8 hours to begin today's hazardous operations. Just before we began the webcast, the SpaceX launch director polled the 9 members of the launch team and got a go for both propellant loading and for launch. Now, we're currently loading propellant on all 3 first stage boosters and the second stage. Now, our propellants are an oxidizer, liquid oxygen, and a fuel, kerosene. Why did we pick these 2? Well, obviously in space there's no oxygen needed to support combustion. So we bring our own as liquid oxygen. It's readily available and it supports efficient combustion. We chill it to get it as dense as we can in order to maximize how much we can load onto the rocket. Our fuel is RP1, essentially a purified kerosene. It is safe, easily available, has a lot of history. The Saturn V first stage flown from this very pad on the moon missions used liquid oxygen and kerosene. Now on the spacecraft side, the arabsat 6A team began transfer to internal power at T-minus 21 minutes, and just a few minutes ago they completed that. They are go for launch. Now for tonight's mission, we're using the Falcon Heavy to place the satellite into an orbit with an apogee near 90,000 kilometers. This is much higher than the apogee of a normal geotransfer orbit. With this higher apogee, it is more efficient for the satellite to maneuver into its final geo orbit. The range is currently green. They are prepared to support today's mission. And for the weather, the good news is the upper altitude winds are much lower today, so both ground level and upper altitude winds are go for launch, no worries there. Now, as Jesse mentioned, we did start the day with a 2-hour launch window. However, now that we are into LOX loading, we don't have the ability to hold the countdown. If there is an issue in the last minutes, there isn't enough time in the window to stop, reload the cold liquid oxygen, and still launch today. There is a backup date, though, this Saturday, April 13th at the same time. Now, as I've said before, launch is hard, and Falcon Heavy is no exception. We are essentially counting down 3 rockets simultaneously. So the SpaceX team is going to be conservative in case anything pops up in the last minutes. But as the energy from the team gathering below me outside of the Mission Control Center is growing, we are go at T-minus 7 minutes and 20 seconds.
As we mentioned earlier, the payload being launched tonight is for our customer arabsat, one of the world's top satellite providers in the Arab world, reaching tens of millions of homes in more than 80 countries. arabsat 6A, which was built by Lockheed Martin, is a high-capacity telecommunications satellite that will deliver television, radio, internet, and mobile communications to customers in the Middle East, Africa, and Europe. Here's a quick message from our customer.
One world, one heart. A world so different, yet so alike. Our world. The one and only world, where we feel more at home. A world that's growing wider than ever, with more choices and more possibilities. The world of arabsat. The largest Arab community in the sky, now closer than ever, with the new generation of arabsat satellites. Welcome to our neighborhood. arabsat, our world, your world.
The SpaceX team continues to count down for launch of our first operational Falcon Heavy flight. We're currently T-minus 6 minutes, 10 seconds from liftoff. Now, fuel loading is completed on the Falcon Heavy. Liquid oxygen loading is continuing. We'll wrap up the very last of it at T-minus 2 minutes on the second stage. Now, another event coming up here in a couple of minutes is retraction of the transporter erector. We'll start a sequence at T-minus 4.5 minutes. You should see the clamp arms around the second stage open up. Shortly after that, the strong back portion will recline away from the Falcon Heavy. It moves just under 2 degrees until liftoff, when it will move the rest of the way back from the launch vehicle. Now, a lot's going to happen in the first 4 minutes of flight of a Falcon Heavy. We'll first light the 2 side boosters, and then fractions of a second later, the center core. The flight computer on Falcon Heavy will check power on the 27 Merlin 1D engines, then command release from the ground hold downs at T0. 40 seconds into flight, we'll decrease power on the 2 side boosters in preparation for maximum aerodynamic loads on the vehicle. Once we get through this period, Falcon Heavy will throttle back up to power on the side boosters. Once we get 2 minutes into flight, we will again reduce thrust on the 2 side boosters. At this point in time, the vehicle is much lighter, having burned much of the propellant, but the thrust is constant, so the acceleration, hence the loads, are continuing to increase. So we will reduce thrust on the side boosters to decrease forces on the rocket structure. When we get 2.5 minutes into flight, we'll thoroughly turn off the side boosters, an event called BECO, Booster Engine Cutoff. The pneumatic separation system on the center core then unlocks the 2 side boosters and pushes them away. You've just heard the call out. They're going to begin retracting the clamp arms as part of the TE Strongback retract sequence. Meanwhile, back in the ascent sequence of event, once we get the side boosters separated from the center core will throttle up to full power. It'll run another 55 seconds. Finally, at just past 3.5 minutes after liftoff, the center core will shut down, called Main Engine Cutoff, MECO. The second stage separates. From this point on, it's like a Falcon 9 mission, other than we're having 3 boosters all returning to Earth at the same time. The fairing will separate, the second stage engine fires twice, eventually sending the stage and payload out into geosynchronous transfer orbit around the Earth. So that gives you a feel for the sequence of events we're planning to demonstrate on this flight of the Falcon Heavy. Everybody right now is reporting things look nominal. The checkout sequences are good. We're closing out propellant load at T-minus 3 minutes and 16 seconds and counting. Let's watch and listen in to the final countdown of Falcon Heavy.
Strongback side retract angle of 88.3 degrees.
Stage 2 left close, slow down. Falcon Heavy is on internal power.
Ground gas closeouts is starting. Ground gas closeouts complete.
Go for launch.
Minutes 30 seconds. Minus 15 seconds.
Vehicle's flight pressures.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition, liftoff.
Vehicle's pushing downrange.
Center core beginning deep throttle. Center core at deep throttle.
Plus 33 seconds into flight. Under the power of 5.1 million pounds of thrust, Falcon Heavy is headed to space. We're throttling down at T plus 40 seconds to
Side booster
prepare
throttle
for
bucket.
maximum dynamic pressure.
Power and telemetry are nominal.
We're hearing reports. Power and telemetry are nominal.
Vehicle is supersonic.
You may have heard the call out on
Side
net
booster
one.
stepping up.
Vehicle is supersonic. Side boosters are throttling back up on power as we're
Max
through the
Q.
period of maximum dynamic pressure. Trajectory looking good. You can hear the applause behind me as we've gotten past maximum dynamic pressure. Next event coming up is chill-in of the MVAC-D engine. Get the turbo pump ready to ignite the main engine on the second stage in another couple of minutes. Merlin engine performance looks good. We've begun dropping power on the side boosters to decrease loads on the center core.
Second load limiting shutdown.
Continuing to decrease loads to minimize acceleration on the Falcon Heavy structure. Coming up on booster engine cutoff, called BECO, and separation of the two side boosters.
MVAC engine chill.
BECO.
Booster separation confirmed.
Successful separation, if you can hear me over the cheering. Side boosters now beginning a flip to begin returning back to Cape Canaveral.
Boost back burn.
Side boosters have begun the boost back burn. The center core has throttled back up to power. Everything looking good on the flight of Falcon Heavy. The next major event, main engine cutoff of the center core and separation ignition of the second stage. Bottom middle view shows the view looking up into the nozzle of the second stage engine.
MECO.
Main engine cutoff, center core is shut
Stage
down.
separation confirmed. MVAC ignition.
Again, over the cheering, MVAC-D engine up on power. It looks good. Side boosters looking good, still burning on their way back to Cape Canaveral. Grid fins are out on the center core.
Fairing separation confirmed.
Here comes the fairing separation, and there it goes. We also have successful shutdown of the side booster boost back burn. So T plus 4 minutes, 25 seconds into flight. Side boosters on their way back to Cape Canaveral. Center core coasting out over the
trajectory
Atlantic.
nominal.
Stage 2 looking good with a nominal trajectory.
And as you guys have noticed, the grid fins have deployed on the side boosters as well as the center core. Those work to help guide the boosters back to a nice targeted soft landing. Let's see those heading home right now. As a reminder, today we'll be attempting to recover all 3 of the first stage cores, and all 3 boosters are currently on their way heading home. In just a few minutes, the side boosters will execute an entry burn, followed by a landing burn, and the center core will do much the same a few minutes later. Both burns are meant to slow the stage's speed down rapidly before landing.
At the time of separation, the side boosters were traveling slow enough to turn around and make their way back to land at our side-by-side landing pads. The center core, on the other hand, is going too fast to efficiently return to the Cape, so we're using our autonomous drone ship, Of Course I Still Love You. If we have a successful landing today, the side boosters will be reflown on our next Falcon Heavy mission, STP-2. Now, coming up at about T plus 6 minutes will be the side boosters re-entry burn.
Acquisition of signal Bermuda.
So you'll see the side boosters on your left and right screen.
Side booster entry burn has started.
And there's the re-entry burn beginning.
Stage 2 trajectory nominal.
And the re-entry burn is complete for the side boosters. Now, coming up in about 30 seconds, the center core, which you see on your center screen, will begin its re-entry burn.
Stage 1 entry burn has started. Side boosters are transonic.
And there you can see the re-entry burn for center core has begun. Coming up in about 5 seconds here, the side boosters landing burn will begin as well.
Side booster landing burn has started.
Sight to see.
Now we're waiting for the engine to shut down on the second stage and for the center core to land. Now, if all goes well, we'll have successfully recovered all 3 boosters, which we have never done before. Now, coming up in about 20 seconds, we're going to listen for confirmation of SECO 1, or second engine cutoff 1.
Ship AOS.
Back shutdown.
And we have confirmation.
Center core
Now we're
is
just waiting to hear
transonic.
good orbit.
Nominal orbit insertion.
And we have that confirmed. Good orbit.
Now, coming up here in about 15 seconds will be the center core landing burn beginning. So again, as we mentioned earlier, this is going to be a challenging landing.
Stage 1 landing
And we
route
are
is starting.
landing on our drone ship, Of Course I Still Love You. And
Center core landing routes are deployed.
Looks like we lost the live view. Waiting for some confirmation, and it sounds like we landed the center core on our drone ship. We have landed the center core for the first time on our drone ship. Of course, I Still Love You. For the first time, we've landed all 3 boosters for Falcon Heavy. What an amazing day. So now we are going to take a quick break. You can hear our crowd going wild. 3 for 3 boosters today on Falcon Heavy. What an amazing accomplishment. So now the primary mission is still going well. We are about to enter the coast phase, so we're going to take a quick break. But we'll leave you with an animation that shows you where we are throughout the coast phase. We will be back at about T plus 26 minutes for second stage relight and the deployment of our satellite.
Welcome back to the webcast for the arabsat 6A Falcon Heavy mission. We're at T plus 26 minutes, 45 seconds. Second stage with the satellite is about to cross the equator, west coast of Africa. So far today, if you missed it, you missed a great show. Liftoff right on time, 35 minutes after the hour. Side boosters separated as planned. 2 successful landings on landing zone 1 and 2. Center core shut down, second stage separated. Second stage went into the desired parking orbit where we are right now. And the center core executed a toasty landing out in the Atlantic Ocean on the drone ship. Now coming up in about 20 seconds, we're going to get ignition, about a brief reignition of the upper stage engine to carry the payload into the desired transfer orbit.
And back ignition.
Confirmation of ignition. We are up at the desired power. Tank pressure looks good. The turbine temps look good. You may have seen just before ignition the large white fluffy pieces moving away. That is solid oxygen. The stuff you breathe, it's so cold that it's solid, but it is not very dense. It's very fluffy, and it is actually attached to one of the liquid oxygen overboard drain lines that we use. So coming off is normal. Now this burn is about an 85-second burn. In that time, we'll add 2,800 meters per second to our velocity. That's more than the side boosters provided early in flight, almost as much as what the center core gave us. We've throttled down the engine to keep accelerations below the limit for our arabsat customer. Everything continues to look good. The views of the nozzle of the upper stage engine coming from 2 SpaceX cameras on either side of the second stage. Continuing to throttle down, and we have shut down.
And back shutdown.
Right now we're waiting to hear what the final orbit looks like.
Nominal orbit insertion.
Guidance engineer over one of the nets announced nominal orbit insertion. Right where we want to be. We're on a path that'll take us almost 90,000 kilometers up above the Earth. Well, now we're in the good orbit we wanted. We're going to coast for the next 5 minutes or so. We'll be back with continuing coverage at T plus 33 minutes for the final step in today's mission, deployment of the arabsat 6A satellite.
Acquisition of signal, HPK. Signal expected.
Welcome back. T plus 33 minutes, 29 seconds since liftoff. We're about half a minute away from the deployment of the arabsat 6A satellite. Now currently the second stage has begun a slow spin up. That'll help stabilize the satellite. It'll retain that spin when it separates from the second stage. Now, currently the camera view has switched forward looking at the arabsat 6A spacecraft. And if you've just joined us now, you've missed a great day. Both side boosters landed at the Cape. Center core landed, second stage right in the desired orbit. And now we're waiting for separation.
Spacecraft separation confirmed.
As you can tell behind me, the folks who watched the mission cheering. arabsat 6A headed away into the desired orbit, doing its mission in space. That puts a capper on what's been a completely nominal day here at SpaceX.
And with that, that brings our webcast to a close. Thanks to our customer Arabsat for entrusting us with tonight's mission. Thank you to the 45th Space Wing and Range Safety and the FAA for licensing today's launch.
We'd also like to thank all of you, our viewers, for tuning into such an exciting launch today. Follow our website and social media platforms for updates on our next milestones and missions. And until next time, have a great night.